Hello, this is Xu Chen. I'm a postdoc in Academia Sinica. My research interest is in number theory. So let me begin with the Riemann zeta function. So the Riemann zeta function is a very complex variable function, zeta s. It is defined by the infinite series 1 over n to the s, and it is equal to the infinite product over prime p. And each term is equal to 1 over 1 minus p to the minus s. And this kind of product, I mean infinite product in terms of prime p is called the Euler product, and each term is called the Euler factor at p. And Riemann zeta function defined in this way is a convergence for real part s greater than 1. And Euler computed the Riemann zeta function at value zeta 2, and it is equal to pi squared over 6. And he also computed zeta 4, and so on. He showed that actually the zeta n, when you divide by pi to the n, and this ratio is a rational number for all positive even integers n. And this zeta function is a special case of the so-called L function. And my research interest is in the study of this kind of algebraicity phenomena of higher degree L functions. And for example, the Riemann zeta function here is a degree 1. Here the degree refers to the degree of the Euler factor. Okay. So recently, I have been considering a special kind of L function called the symmetric power L functions. And the symmetric power L functions are defined with respect to some input data. Here we take the input data to be the Ramanujan delta function, for example. And the Ramanujan delta function is defined by this formal infinite product. And we expand this formal infinite product with respect to powers of Q. Then we obtain a sequence of function tau 1, tau 2, and tau 3, tau 4, and so on. Tau 1 is 1, tau 2 is minus 24, and so on. And then we define the L function of this Ramanujan delta function, Ls delta, to be the infinite sum, tau n over n to the s. And similarly to the Riemann zeta function, and we have the Euler product. And but this time the Euler factor is degree 2. And it is for each prime, it is equal to 1 minus tau p times p to the minus s plus p to the 11 minus 2s. And this equality follows from the recursive formula for the tau function at p powers. And more generally, we can define the so-called symmetric nth power L function of delta. And it is denoted by Ls delta sin n. Here n is a positive integers. And it is defined by an Euler product. And this time, the Euler factor is of degree n plus 1. And for each prime p and each integer j from 0 to n, the corresponding factor is 1 minus alpha p to the n minus j times beta p to the j times p to the minus s. And here, this alpha p, beta p are roots of this degree 2 polynomial, x squared minus tau p x plus p to the 11. And because tau p now is an integer, so alpha p, beta p are just algebraic numbers. And for this symmetric power L function, Deligne proposed the following conjecture in 1979. And assume n is an even, say 2r for simplicity. Then for all even integers, n lies in between 11r plus 1 and 11r plus 11. And Deligne conjectures that the value Ln delta sin n, then divide by pi to the r plus 1 times n, then times some number c delta sin n. Then he conjectures that this ratio is a rational number, and where this c delta sin n is a number explicitly defined in this way, it is equal to pi to the minus 10 times the Pearson norm of delta, and we raise to some integral power of depending on n. And here this double break delta is the Pearson norm of delta. So this is just like the case of Riemann zeta function, where now we consider the symmetric power L function. And recently we showed that this conjecture holds for n equal to 6. And in fact, what we prove is that we show that this kind of algebraicity result holds with this Ramanujan delta function replaced by any modular form, as long as the weight of the modular form is greater than or equal to 6, then we prove this kind of algebraicity result. We give a numerical example. So we consider symmetry 6 power L function, and we consider its value at 34, and we divide by the proposed period. Then this ratio is approximately equal to the rational number on the right-hand side. So my research is focused on this kind of algebraicity phenomenon for higher degree L functions. And for example, symmetry 6 is a degree 7 L function. Okay, so this is a brief outline of my research, and thank you for your attention.